In this video, I'm going to very quickly show you how we can create Java classes, chain them together, and then compile and run our Java applications. So first thing I'm going to do is I'm going to create the main entry to the program. I always call this app, and I'm going to create a second class which we can then play with. So I've created my two classes there, and here they are. So the app is going to be the entry point to the program. This is always going to basically be the same, but it's any class that holds the main method with lowercase that matches the signature that's being expected. So in this case, make sure it's public class app. Because don't forget, the class, name of class must match the name of the file it's held within. So we've got public class app, again public, and this needs to be static with no return type, main in lowercase, and it's expecting an array of strings. You can call this what you like. By convention, I'm just going to call it args. So that's it. That's basically the entry point to our program. When I come back here once I've created this person class. So again, we want to be able to access it elsewhere. So public class person, and in here I'm going to create a couple of internal fields. I'll make them private. So I've got private string name, private int age. Okay, now because I made these private, I'd have to set up, if I wanted to give external read-write access, I'd have to create a getter and a setter. I'm actually going to create just the getters, and I'm going to have them be set only from the constructor. So the constructor, again, is public. This has the same name as the class itself, and you can always tell if it's constructor because it doesn't have a specified return type. So in here I'm actually going to expect to be given the name and also the age. I'm going to set these values, so I'm going to use the this keyword to show that I mean the variable that's scoped to this object or class. So this name equals name. In this instance, because there was a name clash, if I didn't do this, I'd get what's called shadowing. Preference would be given to the local variable, which means that if I did that, I've effectively overwritten this name with itself. Now this specifies that this name is actually this one here. And again for the age, just a reminder as well that this is the assignment operator. So this is actually setting the value stored in this variable to be equal to whatever's given here. Now in this case I've given two variables, but you could give a string literal or a literal int. So now I'm going to write the getter. So public string get name. Don't need to pass it any arguments because I'm just returning the value here, and return this name. I'm going to copy this, and we're going to get age as well. Last thing I'm going to do is looking a little bit ahead. But if you understand the concept of inheritance, basically all the classes will inherit from a base class, so they actually have some functionality behind the scenes. One of these is the toString method, which determines when you attempt to write an object out to, say, the console, it will attempt to call the toString method to convert that object to a string. So for this we need to use a special bit of code here to override the base class, base method rather. And then this is public string toString. So what this is saying is this now overrides the base implementation with whatever I do here. So now I'm going to return name plus curve braces, age plus, close the braces, don't forget the semicolon. Okay, I think that's alright. We'll find out when we try to build if it works or not. Okay, so now in the main method, this is the start point for our program. I'm actually going to create instantiate the person. So here we have a person instantiated from the person class using the new keyword. Now, I can't do this because I have created my own constructor. So the default constructor that was empty, it doesn't get created. So if I did want to do this, I'd need to provide a specific implementation of an empty or a parameterless constructor. So I do in fact need to give it the name and an age. And now what I'm going to do is I'm going to write this out to the console. And I'm just going to pass it the object. And the reason I can pass this object is because it will call this method here and it will provide this to the console. So I'm going to save that. Let's pop over. Now we need to compile our classes. Now because I have created a link or used the person class inside the app class, the compiler will know that there is a dependency that's there. So it knows that when I try and build app, it's dependent on person, and it will also compile the person class. So Java C app.java, and I'm going to see if we get any build errors. We do. So line 16, person.java. Whoops, it needs to be an integer. Okay, that seems to have built. And if I show you the files here, you can see that not only has it produced the app.class, but it's also then built the person.class in one go. So I would always tend to build from the base class, because that should have the full tree. Now we're going to run this, and in order to run the program, we need to give it the fully qualified name to the class that we want to run. In this case, we want to run app. Now, because we haven't got this inside an assembly, there's nothing preceding this. Later on there may be. But in this case, you don't do the suffix. That literally is the fully qualified name of the app class there. So go to run that, and as you can see, it outputs the name and age as specified.